The space station was still in orbit. It was still intact. It had simply stopped answering. On the 11th of February, 1985, Soviet flight controllers watched every signal from Salyut 7 disappear. Commands were transmitted. Nothing came back. Telemetry vanished. The continuous stream of measurements that described the station's electrical systems, its orientation, and the conditions inside simply stopped. There was no warning of an explosion, no sign of a collision, only silence. Yet one source of information never changed. Radar continued to detect the station exactly where it should have been. The station never left its orbit. Radar confirmed it. Yet every orbit raised the same unanswered questions. Was it still pressurized? Did any electrical power remain? Was anything inside still alive? Mission Control could still see the station. They could no longer see what mattered. The obvious assumption was that engineers would diagnose the problem from the ground. Normally, telemetry would reveal exactly where the failure had occurred. That assumption depended on one thing. The station had to answer. It never did. Mission records confirmed something far more serious than a communications failure. Every command went unanswered. Every telemetry channel remained silent. Without electrical power, the station could no longer report what had happened inside. Ground controllers could no longer examine the station from Earth. That changed the investigation immediately. Without telemetry, every familiar diagnostic tool disappeared. No one could measure the batteries, the cabin temperature, or even whether the guidance system still worked. What was waiting inside? Tracking stations continued to follow the silent laboratory as it crossed the sky. The records revealed one more crucial detail. The station was not tumbling wildly. It was rotating slowly around a single axis. That distinction mattered. A violently spinning station might never be reached. A slowly rotating one might. But before anyone could think about reaching it, they first had to accept a new reality. Salyut 7 was no longer just another space station waiting to be repaired. It had become an object that nobody on Earth could accurately describe. And until someone could stand beside it, open its hatch, and see what remained inside, every plan to save the station would begin with the same problem. Nobody knew what they were trying to save. A rescue mission now faced a problem unlike any attempted before. The destination was known. Its condition wasn't. Reaching the station would normally be the simplest part of the mission. Soviet spacecraft were designed to dock automatically. Radar systems measured distance, calculated closing speed, and guided both vehicles together with remarkable precision. Salyut 7 could no longer participate in that process. Its guidance system was silent. Its docking equipment could no longer communicate. Its automatic rendezvous system was effectively gone. The crew would have to do the work themselves. That changed the mission before it had even begun. The challenge was no longer reaching orbit. It was docking with a spacecraft that could not cooperate. One mistake during the final approach could end the mission before anyone reached the hatch. The obvious assumption was that the station might be spinning uncontrollably. Many early reports suggested exactly that. The documented flight records told a different story. As the Soyuz spacecraft closed the distance, the crew observed that Salyut 7 was rotating slowly around a single axis. It was uncontrolled. But it was predictable. That small difference made the rescue possible. Instead of allowing the automatic docking system to take over, the crew relied entirely on manual flying. Through an optical sight mounted inside the spacecraft, they watched the station grow larger against the darkness of space. Distance was measured with a handheld laser rangefinder. Every correction came from the crew's own observations. There was no automated system quietly solving the problem in the background. Every movement had to match the station's slow rotation. Too fast, and the docking probe could strike the station. Too slow, and the opportunity would drift away. The closer they came, the smaller the margin for error became. From a distance, Salyut 7 looked almost unchanged. Its solar panels still stretched outward. Its familiar shape was unmistakable. Nothing on its exterior revealed whether the systems inside were merely dormant or permanently lost. The station offered nothing. No guidance. No confirmation. No warning. Only a docking port turning silently above Earth. After carefully matching the station's motion, the Salyut spacecraft closed the final distance. The docking probe engaged. The locks closed. The two spacecraft became one. The most dangerous part was over. But the investigation had not truly begun. For the first time since the station had fallen silent, human beings stood on the other side of its hatch. Only one question mattered now. What would they find when they opened it? The hatch opened into uncertainty. Before entering the station, the crew carefully equalized the pressure between the two spacecraft. If the pressure had fallen, it would have meant the station's hull had been breached. It had not. The pressure remained intact. That answered one question. Many more remained. The hatch slowly swung open. No lights came on. No ventilation fan started. No familiar hum of electrical equipment filled the cabin. Only darkness. The beams from the crew's headlamps became the station's only source of light. As they floated inside, another reality immediately became impossible to ignore. The air was bitterly cold. Their breath condensed into visible clouds that hung motionless around them because the ventilation system was no longer running. Every surface reflected the narrow beams of their lights. Control panels. Handrails. Bundles of electrical wiring. All of them were covered by a delicate layer of crystalline frost. The station had not burned. It had frozen. Recorded observations placed the temperature inside at roughly 10 to 15 degrees below 0 Celsius. The insulation trapped what little heat remained. When the heaters failed, that warmth slowly disappeared until the station froze. The obvious response might have been to restore power immediately. The crew refused to do that. They had no idea which electrical circuits had survived. Ice covered cables and equipment throughout the station. As the station slowly warmed, melting frost could create electrical shorts in systems that might still be recoverable. Turning everything on at once could destroy the very hardware they had come to save. Repair would have to wait. Diagnosis came first. The crew moved slowly from compartment to compartment, not searching for a single broken switch, but building a picture of an entire spacecraft that had been silent for months. Every instrument panel was examined. Every accessible cable was inspected. Every observation narrowed the range of possibilities. The station no longer looked like an abandoned machine. It resembled a critically ill patient whose condition had to be understood before any treatment could begin. The darkness no longer represented mystery alone. It became evidence. every frozen control panel, every silent fan. Every untouched layer of frost revealed another system that had stopped working, and another that might still be waiting to respond. The mission had changed once again. The crew had not entered the station to repair it. They had entered to discover whether it could still be saved. And somewhere behind those frozen panels, one surviving electrical path would determine whether the station's recovery could even begin. The first meaningful measurements came from the batteries. Until that moment, nobody knew whether the station still possessed any usable electrical power. If every battery had been completely discharged, the mission could end there. The crew began checking them one by one. Not through the station's control panels. With a handheld voltmeter, every reading mattered. Each measurement replaced another assumption with evidence. Some batteries were beyond recovery. Others still held enough remaining charge to offer a possibility. The station was not electrically alive. But it was not completely dead either. That single discovery changed the investigation. Recovery was no longer a question of replacing the entire electrical system. It became a question of reaching the surviving parts without destroying them. The obvious solution was impossible. The charging system no longer worked. The electrical path between the solar arrays and the batteries had failed. No switch inside the station could restore it. The crew would have to create a new path themselves. Using emergency electrical schematics and their own measurements, they identified a way to bypass the failed charging block. Raw copper jumper wires were connected directly between the solar arrays and individual battery terminals. It was not an elegant repair. It was a deliberate bypass built inside an orbiting spacecraft. The automatic system remained unusable. The crew replaced it with their own hands. Then they waited. Nothing happened immediately. The solar arrays needed time to rebuild the batteries one cell at a time. Every hour of sunlight became part of the repair. Slowly, the electrical reserve began to grow. Then came the first unmistakable sign that the station could still respond. A small group of instruments came back to life. A few indicator lights appeared where there had only been darkness. For the first time since the station had fallen silent, it answered. The temptation was to believe the crisis was over. It was not. Electricity alone could not make the station habitable. The heaters were still cold. The ventilation system remained silent. Frozen water lines still blocked the environmental systems. Attitude control had not returned. Telemetry had not yet been fully restored. Restoring one circuit only revealed how much work remained. The station had shown its first measurable sign of life. Now, every remaining subsystem depended on what the crew chose to restore next. The return of electrical power did not make the station operational. It made the next repair possible. As more batteries recovered their charge, the crew could begin restoring systems that had been dormant for months. The first priority was heat. Without it, the station could never become a safe place to work. The electrical heaters were brought online gradually. There was no attempt to warm the entire station at once. Every increase in temperature had to be controlled. Too much heat, too quickly, would turn the thin, crystalline frost coating the station into liquid water. That water could spread across electrical equipment that had survived the power failure. The crew allowed the station to recover slowly. The cold retreated compartment by compartment. Frost disappeared from handrails. Instrument panels became visible beneath the ice. Plastic sheets were positioned beneath sections of the ceiling to collect melting droplets before they could reach sensitive equipment. The station was warming. The next challenge was air. For months, the ventilation fans had remained silent. Without moving air, carbon dioxide collected wherever the crew happened to be working. Even inside a pressurized spacecraft, breathing could become difficult if the atmosphere no longer circulated. The crew improvised. While waiting for the ventilation system to return, they waved pieces of cardboard through the cabin to push fresh air toward one another and disperse the pockets of carbon dioxide forming around their heads. It was a remarkably simple solution. Yet inside a powerless spacecraft, it allowed them to keep working until mechanical ventilation could be restored. As electrical capacity continued to improve, more environmental systems gradually returned. The ventilation fans began turning again. Warm air started moving through the station. The stagnant atmosphere slowly disappeared. Only then could attention shift to another critical problem. The station's water system had frozen solid. Months without electrical heating had left water trapped inside the plumbing as ice. The crew could not simply force the system back into operation. It had to thaw naturally, patiently, section by section. Only after the lines had warmed sufficiently could the water recovery system begin functioning again. Each restored system unlocked the next. Electricity made heat possible. Heat restored ventilation. Ventilation made sustained work possible. Thawed plumbing completed life support. The station was no longer recovering through isolated repairs. It was rebuilding itself as one interconnected system. There was still no final proof that the rescue would succeed. One major system remained absent. The station still could not reliably control its orientation. Without attitude control, every restored subsystem remained vulnerable. The station was alive again. But it still could not fully take care of itself. By now, the station no longer resembled the silent shell the crew had first entered. Lights illuminated sections that had been completely dark. Warm air moved through compartments that had been frozen only days before. The familiar interior of Salyut 7 had returned. But one essential capability was still missing. The station could survive. It could not yet operate. An orbital station does not simply float through space. It must continually know where it is pointing. Its solar arrays must face the sun to produce electrical power. Its antennas must point toward Earth to exchange information. Without attitude control, every restored system remained dependent on chance. The batteries had been revived. Now the station had to learn how to hold itself in space once again. One subsystem after another returned to service. Guidance equipment was brought back online. Control systems responded. The station slowly regained the ability to orient itself instead of drifting through orbit. That achievement changed everything. For the first time since the station had fallen silent, the recovered batteries were no longer being slowly exhausted by an uncontrolled spacecraft. They could now be replenished as the solar arrays once again maintained their proper orientation toward the sun. The recovery had become self-sustaining. With stable electrical generation restored, communication systems followed. Telemetry began flowing back to mission control. After months of silence, engineers on the ground could finally see what the station itself was experiencing. Temperatures, electrical status, system performance. Measurements once lost had returned. The station had begun answering again. That changed the mission for everyone. Until this point, every decision had depended almost entirely on the crew's direct observations. Now the investigation expanded beyond the station itself. Mission Control could compare incoming telemetry with the crew's measurements. For the first time since the failure, Both sides were looking at the same spacecraft. One final test remained. A repaired station had to prove it could function as an orbital station again, not merely as a place where two men could survive. That proof arrived when an automated Progress supply spacecraft approached Salyut 7. Unlike the rescue mission, this docking depended on the station behaving like a functioning spacecraft once more. The approach proceeded normally. The docking was successful. The station accepted supplies exactly as it had before the failure. That single event verified something no individual repair ever could. The electrical system, environmental controls, guidance equipment, and communications network were now operating together as one integrated spacecraft. The same interior that had first appeared as a frozen, silent compartment illuminated only by headlamps had become a working orbital laboratory once again. Nothing about its structure had changed. Only its condition. Months earlier, Mission Control could see the station, but could not understand it. Now every essential system could once again be measured, monitored, and controlled. Salyut 7 had not survived because of one dramatic repair. It returned to service because each interconnected subsystem was restored in the only order that allowed the next one to survive. The station that once drifted silently above Earth, unable to answer a single command, had become a functioning spacecraft again through documented engineering, disciplined diagnosis, and one verified recovery after another.